Okay, so let's try 7A from Unit 9.2. This is what we did in class for those of you that weren't there. And so this limit actually does exist. And as I mentioned in class, that's harder to prove than showing that a limit doesn't in multivariable. So in order to figure out what it approaches, let's look at a few different paths that go to 0, 0. So one of the tricks that I mentioned in class today was that you can, instead of just looking at like y equals x or y equals 2x, you can examine all the lines that go through the origin at once, y equals mx. So if we do that along this path, which goes through 0, 0, then the limit of that function can then be manipulated so that it's now 3x squared times mx over x squared plus mx squared. And that's going to turn into, let's see, 3x cubed times m over x squared, and I can factor out an x squared and I get 1 plus m squared. And then two of the x's will cancel, and I'm left with 3xm over 1 plus m squared. And at that point I can plug in the x equals 0, or x goes to 0, I guess. And so we end up with 0 over 1 plus m squared, which is 0. So that implies that it's going to be 0. That's what we're hoping. So I'll show you one other thing that we can check here. So let's check along a nonlinear path, like y equals x squared. Or you could do x equals y squared too, as long as it goes through 0, 0. So if I do this one, limit as xy goes to 0, 0. Now I'm switching all the y's to x squareds. So this becomes 3x squared times x squared over x squared plus x squared squared. So if I simplify this a little bit, then we get 3x to the fourth over x squared plus x to the fourth, which I can then simplify a little bit more. Limit as xy goes to 0, 0. Let's see, that'll be 3x squared over 1 plus x squared. And then I can plug in the zeros now, and I get 0 over 1, which is 0. Did I do that right? Yeah, I think so. Yeah, that's right. Okay, so so they both go to 0. At this point, you can probably guess that it's going to turn into 0. You can analyze a graph to see that it looks like 0. So I'm going to say here, seems like the limit as xy goes to 0, 0 of, and I'll call this thing here, we'll call that f of xy equals 0. So now comes the hard part, which is proving that. So in order to prove that, let's look at the formal definition. So the formal definition says that if the limit as xy goes to ab of f of xy equals L, that's the same thing as saying for every epsilon greater than 0, there exists a delta greater than 0 such that if 0 is less than this, the distance between xy and AB is less than delta, then f of x and L are going to be within epsilon units of each other. And then this thing right here, since we have it in a couple dimensions, we can rewrite this as 0 is less than or equal to square root x minus a squared plus y minus b squared is less than delta. And for our specific example, this is going to be 0 is less than or equal to x squared, because a and b are 0 and 0, so x squared plus y squared less than delta. And this is for our specific example. This one would be let's see, f of x, xy is 3x squared y over x squared plus y squared. And we think that L is 0, so we're just aiming for this. Okay. We need to start with something, and we do this the same kind of way that we do the 2D proofs. So we'll start with manipulating this sort of thing, and hopefully we can link up the epsilons with this sort of thing with the deltas here. So let's look at that. Okay, so I'm going to start out with pre-proof. So we can pick any epsilon we want, and I have to come up with a delta related to that somehow. So let's start out with the epsilon term, which is 3x squared y over x squared plus y squared, less than epsilon. Okay, so there's some manipulation that goes into this. And this is why it's not easy to do these things. So one of the things we can do, absolute values don't apply to the entire thing because x squared is always positive, y squared is always positive. So really the only thing here that we need is to put the y in absolute values. Okay, now another trick is over here, I'm going to put this over here. X squared over x squared plus y squared, that's always less than or equal to 1. So just kind of think about why that is. Just realize that everything's positive there, or 0. And basically if x squared is some number, x squared plus y squared has to be bigger than that, right? So, or equal to it. Okay, so what I can do now is rewrite this so that I can say 3x squared absolute value of y over x squared plus y squared is going to be less than or equal to 3 times the absolute value of y, because everything else is going to be less than or equal to 1. Absolute value of y is the same thing as saying square root of y squared. And the square root of y squared is always going to be less than or equal to the square root of y squared plus x squared. So right here, and then I need all of this to be less than epsilon. So if I make this side less than epsilon, actually no, let's make that equal epsilon. So if I make this side equal epsilon, at least it's going to be greater than or equal to this thing over here. Right? Whoops. Uh-oh. Okay. So in class we were kind of stuck as to how do I get rid of the equals sign and just make it less than, but that'll fall out as we keep going here. So at this point now, let's look back up here. I've got something related to this. I've got my square root x squared plus y squared, but times 3. So if I divided that by 3, then I can say, this implies right here, implies we should let, let's see, epsilon, or delta to be a third of epsilon. So let's take a look at this now. So here's the proof part. Okay. So for every epsilon greater than 0, we're going to choose delta to be epsilon over 3, which also has to be positive. So now we've gotten this part taken care of, right? And so then the if part that we assume, such that if 0 is less than, let me do it in square root form. Square root x squared plus y squared is less than delta. Then And so now I can manipulate this stuff. So let's see. I need this. This is 3x squared y over x squared plus y squared minus 0, really, because it's f of xy minus L. So I'll just put that there. Now, we've already manipulated this a bunch. We know that this has to be less than or equal to 3 absolute value x squared plus y squared. Now, that has to be less than 3 delta based on the if, right? Less than 3 delta. And so this 3 delta out of here is the same thing as 1 epsilon. So what I have here is if 0 is less than the square root less than delta, then f of x minus L is less than epsilon. So that's actually what the whole proof is saying here. If this is true, less than between 0 and delta, then this is true. That's what we just proved. And that's the definition of a limit there. So by definition of limit, we have limit as xy goes to 0, 0, f of xy equals the limit that we found, which was 0. Okay, now that's sort of a painful way of doing it. There were a lot of tricks involved there. I want to go over one other trick that we came up with in class, and it's called the squeeze theorem. And the way that the squeeze theorem works is it's if you in 2D, the way the squeeze theorem works is if you have some function up here f, and you've got another function here g, and you're looking at some function here h. And let's say we don't know anything about h except that it's, and I'm looking for the limit right there. And if you don't know what h is, but you know that it's squeezed between f and g at that one point, you can find the limit of f at that point and the limit of g at that point, show that they're the same, and then h would have to have the same limit because it's squeezed into that spot. So the idea here is that we can do the same thing but with multivariables. So instead of curves, it's like f is a surface, g is a surface, h is a surface between the two, and they all meet at that one point in the middle, and you can figure out what that limit should be by looking at the limits of the f surface and the g surface. So an alternate solution for 7a would be this. 3x squared y over x squared plus y squared. That's always got to be, whoops, sorry. That's always got to be between 3 times the absolute value of y and negative 3 times the absolute value of y. I mean, you can kind of think about why that is, but that will definitely work. So now, if I take the limit of each of these as xy goes to 0, 0, negative 3 absolute value of y, that's always got to be less than or equal to the limit of xy going to 0, 0 of 3x squared y over x squared plus y squared, which has to be less than or equal to the limit as xy goes to 0, 0 of 3 times the absolute value of y. And if I take the limit of this one on the left side, that's 0. And if I take the limit of the one on the right side over here, that's 0 too. So that forces this guy in the middle if that's between 0 and 0, then it has to be 0 too. So let's see, can I just copy this? Copy, paste. So therefore, this has to equal 0 by the squeeze theorem. The squeeze theorem has a bunch of names. It's also called the sandwich theorem pretty commonly. The pinching theorem, I think it's also called. So anyway, that's how that works. That will definitely come in handy for doing 7b. 7b has a similar approach, and I think this is probably one of the easier ways of doing 7b. Turns out some of these you can also use polar coordinates for, so 7b is one of them. So if you're doing the homework and you want to try that, see if you come up with it. Okay, and hopefully